Hello children, you are welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. I'm Onkwagbaji, and I trust you've been enjoying your day so far. Today in mathematics, we will continue with our work on values and place values. I'm sure you had some fun learning in the last lesson. So we'll move on to today's work. What are our learning objectives? By the end of this lesson, you should be able to differentiate between the value of a digit and the place value. Yeah, they are two different things. Value is not the same as the place value. So we've talked about value, but what is the place value? You'll learn that today. What else? You should be able to state the place value of digits. Okay, so when you're able to state the value, you should also be able to state the place values. Now, finally, you should be able to order whole numbers or arrange whole numbers using your knowledge of place values. These are the things that we should be able to do at the end of the lesson. So sit back, relax, drop your pens, papers, and listen to Onkwagbaji as I show you the way. Okay, now every digit in a number has a unique position. Remember what we did in the last lesson. If it's in the first position, it counts singles. If it moves to the left, then the value changes. And then as it moves to the left, the value changes, keeps getting higher. The position will now determine the value. Okay, so the way you put the digit determines what the value will be. Sometimes if you put a 2 somewhere, it could be 20. The value could be 20. Sometimes it could be just 2. Sometimes it could be 200, and it could be 200, it could be 2,000, it could be 20,000, and so on and so forth. So it is the position that determines what the value will be. Where you put it is what determines the value. Now these positions, they have names. You know, under the ones you have 3 rooms, under the thousands you have 3 rooms, under the millions you have 3 rooms. So each of these rooms, they have their own unique name, and this name is what we call the place value. Okay. Okay, so that's position where a digit finds itself. That position where you put a digit is what we call the place value of that digit. So sort of like, think of it like the value of that place. Okay, so in the first place you are counting 1, so that's the value of that place. Then the next place, you're no longer counting 1, so you're counting in 10, 10, 10. So that's the value of that place. And when you move it to the next place, you'll be counting in hundreds. That is the value of that place. So as a digit moves to the left, the place value changes and increases 10 times. So you start counting in ones, then you start counting in tens, and then 10 times 10, 10 in 10 places. When you count 10 in 10 places, you have to move the 1 again to the next place, then you count in hundreds like that. And when you count 100 again in 10 places, you have to move the 1 to the next place, and that's the first place under the thousands. So let's move on. Now, here is an example of what we're talking about. The place value of a digit is different from the value of the digit. Now, in this case, the value of 3 is 300, and that is because when we talk about these 3, we're not talking about ordinary 3 squares. We're talking about these bigger squares that have 100 squares each inside. So like I said, well, by the time we get here, we are no longer counting in tens, we are counting in hundreds. So what are we counting in? We're counting in hundreds. And so the value is 300 because there are 300 in 3 places. But the place value is 100 because when we get to this point, we are counting in hundreds. So this point, this position is the hundreds place, the place where you count hundreds, and that's the place value. So when they ask you for the place value of a digit, it means when you get to this place, what are you counting? We are counting in hundreds. So the value of 3 is 300. We've done that in the last lesson. But the place value of 3 here, 3 is in the hundreds place. It's counting 101. So 3 is in the hundreds place. So the place value of 3 here is this 100. It is not 300, it is 100. You'll get more chance to see what we're talking about in a few moments. Here, the value of 5 is 50 because, you know, 10, 20, 30, 40, 50. That's what 5 represents. But 5 is counting what? It's counting strips of tens. 5 is counting in tens. It's not counting single squares. It is counting 10 squares together. 10, 20, 30, 40, 50. The value of 5 is 50. But the place value of 5 is tens because 5 is counting 10 strips. And the place value of 2 is just 2, because 2 is counting, 2 single squares. So the place value of 2, the value of 2 is 2. But what is 2 counting? 2 is counting single squares. So we call that, you can say it is counting ones, or you can say it is counting singles, or you can say it's counting units. So I use U to represent units, which means a single square or a single quantity. I use T to represent tens, and I use H to represent 100. Now let's move on. Now we have bigger numbers here. Here, the value of 8 is 8,000. Very easy for us to see that the value of 8 is 8,000. And that is because if I write 8 and I fill 3 zeros, I get 8,000. So the value of 8 is 8,000. No doubt about that. We already know that. But what are we counting in? What is 8 counting? Now, this position, when you get to this position, you're not counting in hundreds. You're counting under thousands. You're counting single thousands. So under thousands now we'll have 100 tens and units. So here you are counting single thousands. It's going to be more than 100, because 100 in 10 places you get to the single thousand. Let's count it. Skip count with me, please. Hundreds. Let's go. 100, 200, 300, 400, 500, 600, 700, 800, 900. And after 900, remember, we have to go to 1 and we shift that 1 to this place. So we'll now be counting 1,000. So this point is counting in unit thousand or 1,000. And likewise, the value of 9, by the time you finish counting singles, you're done counting 1,000, 1,000, you graduate to counting 10,000. So the place value here is 10,000. So it's very easy to see. It's just that you draw your normal values that we used before, and under each you write 100 tens units. So you have, for the first place, unit thousand, 10,000, and then after that you start counting in 100,000. So the value of this position is 100,000, and that is why this is 100,000. If this is 2 that you have here, the value will be 200,000. So again, place value here is 100,000. Place value here is 10,000. That's why the place value of 9 is 10,000. 9 is in the 10,000 position. Where did that go? Okay. All right. So 9 is in the 10,000s position. So let's see the next one. Now the place value of 1 is, the value of 1 is 100,000. Because if I put 1 here, I'll put all the zeros, I'll get 100,000. But the place value is 100,000. So it's very easy to identify the place value. Write the values we were using before: 1,000, ones, thousands, million. But under each, you now put, there are 3 rooms. First one will be units of whatever you're counting, tens of whatever you're counting, 100 of whatever you're counting. In this case, it is 100,000 for 1. Okay, so the place value of 1 is 100,000. But the place value of 1 is 100,000. That's the place value. Value is 100,000, 100,000. The place value is 100,000. Let's see an example. We have to complete the value and place value table for 12,654,104. So let's see what that gives us. With 1 is in the 10 million position. I'm going to show you why. Okay. So if I have ones here, now if I have thousands here, and if I have million here, then you begin to see that 1 is the value of 1 is 10 million, because I'm going to have 1 and 0, that's 10 under million, and the rest will be zeros. But the place value of 1 is, you're going to have units, tens, there is nothing under the 100 place. So the place value of 1 is 10 for million, and that's why you have 10 million. Now for 2 is under unit million, so you can see, you can just write unit million, or you can just write it as million. It's the same thing. Then for the thousands place, I'm going to have my 100 tens in units. So for the place value of the place value of 6 is 100,000. So as you can see, 100,000. Then 5 will be 10,000, while 4 will be unit thousand. And finally, for the ones place, I'm going to have 100 tens units. So 1 will be in the hundred position. You don't write hundred ones, just write hundreds. And then 0 will be in the tens place, and then 4 will be in the unit place, as you can see. So that's how we pick it out. The values are what you've already been taught before, so we will not waste too much time on this. Now let's see what we have in the next screen. The place values helps us to arrange numbers. Okay, if you want to arrange from the biggest to the smallest, or from the smallest to the biggest, the easiest way to arrange them or to know which number is bigger than which one is to check out the place values, the position of the numbers, as you will see. So let's have an example of how to apply this. This example says we should arrange these numbers from the smallest to the biggest, and these are really large numbers, 6 trillion, 6 trillion something, 6 trillion something. So the first thing we want to do is that we're going to put each of these numbers under place values, you know, put them on ones, the thousands, the millions, the billion, then the trillion. Then we now start comparing from the largest place value. In this case, the largest place value is the trillion, okay, the units of trillions. So, but they are 6666. They are equal here, so we can't tell which one is the smallest from this place value. So we'll move on to the next largest place value, and that is the 100 billions. So here it is easy to see that we have 600 billion for this one, 100 billion for this one, 900 billion for this one, and then 100 billion for this one. Now, okay, so the smallest number now will be the one with the smallest 100 billion, and obviously it is this one that has no 100 billion. So we label this as a 1. So this is the smallest number, number 1. Remember that we are arranging from the smallest to the largest. Then we pick the next one with the smallest 100 billion between the remaining 3, this, and this. And this is the one with the smallest 100 billion now, the one with 100 billion. So take that as number 2. Now we're left with this and this. And this one has 600 billion, this one has 900 billion. So this one is the smaller one. So we take that as number 3. And finally, this is the largest, so we take that as number 4. Then the next thing to do is just to rearrange for the teacher so that the teacher can say, and this is it. So the smallest number goes on top, and followed by the next smallest number, 0. You can see that I've arranged the 100 billion, 0, 1, 6, and 9. So this is the order of arrangement. Let me give you something to practice with. You have to arrange these numbers from the largest, careful, from the biggest to the smallest. So you have 30 seconds to do this. Begin. Alrighty then, I believe you've arranged from the largest to the smallest. So we'll just take the same procedure. We will arrange the digits under place values, as you can see. So we have the ones, the thousands, the million, the billion, and then the trillion. Now observe that all of them have the same number of trillion, 300 trillion throughout. So we'll move to the next largest, and you observe that they still have the same 100 billion, 4, 4, 4, 4. So then we'll move on to the next one. And then you see that this one within 9 is the largest on this line. That's the 10 billion, 9, 10 billion. So we take that as number 1, followed by this one with 8. So followed by the one with the 7, and then followed by the one with the 1. So this is the order of arrangement. So we just arrange, take the largest one, put it to the top, and bring the smallest one downwards. So this is our order of arrangement. So now I'm going to give you some assignments, something to practice with. You have to copy this assignment in 30 seconds. But don't go away. Remember that today is Magic Tuesday, and I will be right back. Hello children, you're welcome to this segment of the program. It is Magic Tuesday where I show you a lot of tips and tricks in mathematics. We've learned so many things in this section. Now today's magic promises to be very, very interesting. We will learn how to subtract numbers quickly from round figures. And by round figures, we mean numbers like our place values, 10, 100, 1000, 10,000. So we will do this in just 3 seconds. So you don't have to worry yourself about borrowing or carrying. Watch and learn. This example says subtract 379 from 1000. See, 379 is a 3-digit number, 1000 is a 4-digit number. So how are we going to subtract it without borrowing, carrying, or using a calculator? And we can do it in just 3 seconds. Watch. First thing that you do is that these numbers are arranged and you have 100 things and unit. Now you don't need to put this. You put this there. I'm just putting this there to guide you. You have to make the unit digit, you make it up to 10. So in the unit place you have 9. What do you add to 9 to get 10? It's just 1. So you make it up to 10, that's 1. Then the remaining digits, you make them up to 9. All these other digits, you make them up to 9. 7 plus 2 will give you 9. 3 plus 6 will give you 9. And you have 621. That's your final answer. Again, the unit digits make it up to 10. The remaining digits make them up to 9. And you have your answer. So 7 plus 2 gives you 9. 3 plus 6 gives you 9. It's as simple as that. No borrowing, no carrying. Are you confused? Let's check out another word. This example says subtract 7,842 from 10,000. Now, big number. Don't bother writing anything. All you have to do is just put them on the place values. Make the unit digit up to 10. 2 plus 8 will give you 10. So you put 8 down there. Now the remaining digits, just make them up to 9. So in this case, 4 plus 5 will give you 9. 8 plus 1 will give you 9. 7 plus 2 will give you 9. You have your final answer. 2,158, my friend. That was very easy. Take your time, practice on your own. That's it for today. Till I come your way in the next lesson, remain wonderful mathematicians.